Welcome back. Earlier lecture we have studied about joint distribution and all that. Now we are heading towards the normal distribution. So before heading to normal distribution, we need to know skewness and kurtosis. So what is skewness? Skewness is a measure of symmetry. This can also come in your exam as a MCQ. Skewness is a measure of symmetry. Remember that. Or more precisely, the lack of symmetry. Skewness is a measure of asymmetry of the probability distribution of a real valued random variable about its mean. Remember this, real valued random variable about its mean. The skewness value can be positive, 0, negative, or undefined. So this is symmetrical distribution. In symmetrical distribution, we also call this normal distribution. So in this distribution, mean, median, and mode, they all lie in the center at same place, and you get a normal distribution. See that? This is your normal distribution. Now, negative skew is when your tail is on this side. In this distribution, you will have mean first, then median, and in the center you have mode. You will always have mode in the center. See the positive one as well, that's also in the center. But what will happen in positive? Your mean will lie over here, median will lie over here, but your tail will lie on this side. So the difference between negative and positive is just the tail. Now let's understand by the definition, example, and the formula. So this is the data we have. So for example, in your exam, you have this data. We have already calculated on this data mean. The mean of this data set is 9.22. The median is 8. Mode is not available. Standard deviation 5.92. So we have calculated all this data. Okay. So in your exam, you might have a data and you may have been given this or no, but you can calculate. It's very easy to calculate mean, sum them up and divide by 2. Like we have discussed in previous lectures, what is mean, median, mode, and how to calculate standard deviation. Now, as per Pearson coefficient of skewness formula, mean minus mode divided by standard deviation. But in this question, in this data set, we don't have mode. We don't have mode available. In that case, you will use this formula. So mean, you know the mean was 9.22, but mode was not available. Standard deviation was available, but this, because of mode is not available, so this formula you can't use. But you can use this formula. In this formula, 3, you have mean. What's your mean? 9.22 minus median is your 8 and then divided by 5.92. Okay, the mouse is not great to write this, but I hope you will understand what I mean. So this is how you will calculate the Pearson coefficient of skewness. Okay, now there is another formula, Bowles coefficient of skewness. In this formula, Q3 plus Q1 minus 2, this M is Q2 basically. Quartile 2. So you have quartile 3 plus quartile 1 minus quartile 2 divided by Q3 minus Q1. This is another formula, Bowles coefficient of skewness formula, and this is Pearson coefficient of skewness formula. It's very easy to calculate. You can remember these formulas as well, but usually in exam you might have these given as well. Now let's understand the kurtosis. Kurtosis is a measure of whether the data are heavy-tailed or light-tailed relative to a normal distribution. That is, data set with the high kurtosis tend to have heavy tail or outliers. Or it is a measure of tailedness of the probability distribution of the real valued random variable. So in kurtosis, we have three ways to define this. So you have, if the values are greater than 3, it's known as leptokurtosis. If it's equals to 3, it's known as masokurtosis. If it's less than 3, it's platykurtosis. What you need to remember, how the graph looks like to understand the difference between. So when your value is equals to 3, okay, equals to 3, it will be a normal distribution and your distribution will be like this. Now, if it's less than 3, then it's negative and your graph will be like this. But if it's greater than 3, then it's leptokurtosis and it will be skewed like this all the way up. You will have. So usually this kurtosis is only just to identify whether your data is heavy tailed or light tailed. Heavy tailed is like, obviously this is your heavy tailed, yeah, going all the way. Light tailed, this is your light tailed. This is only way, only the reason you use this. Now, what's the difference between absolute versus relative kurtosis? So kurtosis is measured by B2. If the value of B2 is greater than 3, the curve are more peaked than the normal, like we just discussed, leptokurtosis, or you can call that leptokurtic as well. If the value of B2 is less than 3, the curve is less peaked than normal, and you can call it platykurtic kurtosis. If the value is B2 equals to 3, the curve is having normal peak, which is mesokurtic kurtosis. That's the difference between the three of them. Absolute kurtosis is a normal distribution is 3. This value of 3 is taken as a datum to calculate the relative kurtosis, given as relative kurtosis equals to absolute kurtosis minus 3. The relative kurtosis can be negative. We always work with relative kurtosis. Hence, generally kurtosis means relative kurtosis. Hope you will understood this one. It's basically heading towards the normal distribution. So before that, we wanted to just highlight a little bit on this topic as well. So that's why we have discussed this topic. We'll come back again and we will discuss further.